This program was made possible in part by a grant from the National Science Foundation, where discoveries begin. And by contributions to your PBS station by viewers like you. Thank you. High above the Greenland coastline, more than a dozen scientists and their equipment are taking a ride in a military C-130 on their way to study the vast Greenland ice sheet. Each of them represents many different private institutions, universities, and government organizations. Thanks to a special arrangement between the National Science Foundation and the New York Air National Guard, these flights are an integral part of the ongoing research into climate change. Here in Kangerlussuaq, their efforts are coordinated at the International Science Support Station, or KISS for short. One team has traveled from the University of Arkansas and the University of South Florida in order to study a particular aspect of glacial melt, moulins.
So I started out as a physicist studying galaxy formation, but I was also a quite obsessed caver. I sorted out that I could be doing science a lot like physics, but use it to study caves. And eventually that bled over into glaciology because there are caves that form in the ice, and it turns out that these caves are actually quite important for determining how quickly ice sheets will melt.
This afternoon, at some point, we'll get like a big cart, and so in that big cart, it's a big yellow cart.
I first met Jason at a caving convention. Jason's also a caver. And he convinced me that glaciers in caves were scientifically interesting, and it certainly sounded like an intriguing environment to visit. And so during my first postdoc, I got the opportunity to go with Jason to Svalbard in the Arctic to go glacier caving. So we spent quite a bit of time exploring and mapping glacier caves as part of Jason's PhD research.
Joining the team is Vicki Siegel, a professional mountaineer and experienced expedition member. She has spent several seasons in the Antarctic at McMurdo Station and was once Dr. Gully's graduate assistant.
Yeah, so there should be some sort of manual that tells us about this.
Also joining the team is Celia Troons, Dr. Covington's PhD student. She is also an experienced mountaineer and brings to the team several seasons of experience working in the Swiss Alps.
Data loggers and one. I love grad students.
Nice. In case you get hungry while you're setting up the weather station. Yeah.
It will take 4 helicopter flights to bring all of the necessary equipment out to the ice sheet, so each load must be carefully weighed and balanced.
But he and I together have have been trying to get this project funded for about 4 years, and finally, on our 4th try with the proposal, we managed to get it funded.
It is July, and at this time of year, Greenland is under 24-hour daylight. There is no sunrise, no sunset, and it will stay that way all summer long. With the assistance of the Air Greenland ground crew, Dr. Covington prepares to depart with the final helicopter load, for the first of 25 continuous days camped out on the ice sheet. They will have all of the food, fuel, and other essential supplies they need to accomplish their research. So what exactly is a moulin, and why are they so important to climate scientists?
So a moulin is a hole in the glacier surface where you have a stream that flows along the surface, and then it goes into this hole in a big waterfall. And typically these moulins take the water fairly directly to the base of the ice. Moulins are important because the water that goes through the moulin to the base of the ice, it can speed up the motion of the ice, either by lubricating the surface or by providing water pressure that actually lifts up the glacier and reduces the friction, and it allows it to slide more quickly. So what we're trying to understand is this relationship between water going in the moulins and the forward motion of the ice.
This phenomenon, known as the Zwally effect, was first identified in 2002 by Dr. Jay Zwally, a scientist affiliated with the National Science Foundation and the NASA Goddard Institute for Space Studies. There is disagreement in the scientific community on the level of impact this effect really has on ice movement, which the team is attempting to test using a variety of experiments. As the last helicopter flight departs, leaving the team alone on the glacier, the first signs of trouble appear on the horizon: a whiteout blizzard.
So one of the biggest challenges for us this year was that it was much colder than typical, and also we got a lot of snow. So a few hours after we arrived, it started snowing, and at first my reaction was, well, okay, this is the Greenland ice sheet. It snows sometimes. We're going to be stuck here for maybe a day or so while we wait for the snow to melt, and it's clear enough for us to find a safe way to walk around. And at this point, we hadn't really explored around, so we didn't know where it was safe to walk or where there might be crevasse fields. So the snow was really a showstopper until it melted. But then a day passed, and another day passed, and eventually a week passed, and there was still snow. And at this point, we were starting to get a little bit anxious about when we were going to actually be able to do what we had come to do. Also certainly getting a little bit of cabin fever, just being cooped up in the group tent for a week.
Aside from the small survival shelters the team members occupy for personal space, most of their time is spent in the domed group tent, where they prepare all meals and perform their research.
Maybe today is not the best day to recon from the wind.
Yes.
You might find one. You might find one the fun way.
I mean, we can't even see the streams.
It's like it's a forced rest day. Yeah.
You know, you've got the Baton Death March, and now we have the Baton Rest Day.
Each morning, the team has to check in with the KISS station by satellite phone to get the day's weather reports and to coordinate their activities as a safety precaution.
Hey Jesse, this is Vicky up at Gully Camp. We're doing well. Yeah, we got a bunch yesterday. It's clear now, but getting a little windier. We were wondering, is there any kind of extended forecast? We realized the fidelity of it would be lower, but we're just kind of curious if there's a longer forecast. Okay, so she can request a 5-day forecast, and she will do that for the next. She'll request that tonight. Today we've got wind out of the southeast, 8 to 15 knots, going up to 20 in the evening, drifting snow on the ground, no surprise. -10 to -2 Celsius. Tomorrow is going to be cloudy, overcast, wind out of the southeast, 10 to 15 knots. More wind in the morning, dropping off towards the evening, and then -5 to +3 Celsius.
Dr. Gully was only meant to be in camp for the first few days and was due back in South Florida to coordinate a second camp further up the glacier.
Well, not looking good for getting that coolant instrumentation installed in it.
What do we have to learn from you in order to be able to do it?
Like if stuff starts going wrong, it's like anything else. If everything goes right, it's really easy.
Yeah.
But when stuff starts going wrong, that's when it gets harder. I think after you do it once or twice, it's really easy. But I mean, would it be helpful if I stuck out and just did the instrument installation with you guys?
I mean, there's no question it would be helpful, but you have a number of reasons to get out of here. So, yeah.
With their movements restricted, the team decides to handle every aspect of their mission that they possibly can at this point, including setting up a weather station on the outskirts of camp. Anything that is to be installed on the ice for any length of time requires drilling several feet below the ice surface. The weather station will require 6 feet, which calls for several flights of ice drill bits. Meanwhile, Dr. Covington assembles the weather station components and other instruments that they will need to prepare for the month ahead.
I think we should name the weather station Golgotha. We've got everything kind of pulled out of the snow, so it's not going to refreeze. Get the weather station going up. Beyond that, I mean, it's already 2, so I think get the weather station up, get everything organized, and then we'll just wake up and see what the weather's like tomorrow, and we might start probing around for GPS installation locations. Those will probably take all day. Get to move 400 pounds of batteries. Try that. We're first thing that we're going to do is we're going to walk out and find where everything's going to go and mark it, so that we have a safe route identified. Nobody's falling into crevasses. Nobody's falling into crevasses.
So what was the weather forecast? It sounded like it wasn't good.
Yeah, it's not awesome. So today is like this, but with snow.
With snow?
And wind. Tomorrow, so temperature -5 to +3. Tomorrow is same temperature, but winds 15 to 20 with gusts to 40. So we're going to want to get the guy lines out.
So we've got a couple more days of nasty.
So basically, based on that, there's no way that we're getting any kind of instrumentation installed in the Moulin before the 7th, which is my last takeout day to make my flights home. So yeah, I don't know what to do about that. You pass the maple syrup. My answer to that is that we should just open the scotch now.
With high winds approaching, Dr. Gully and the team reinforce the tents by lashing down guy lines. This secures the tents to the ice and gives them a better chance of staying put.
Did I miss one?
On the ice sheet, the tent stake of choice is a length of bamboo pole where thickness, durability, and light weight make it an ideal anchor.
And did you do one for this side?
So one of the few things that we could do while we were snowed in was fly some of the drone vehicles that we had and use that as a way of doing some reconnaissance in the area. So we have a tough wing, which is a plane that automatically flies over a grid and takes pictures. And we're using that to map out the local area to see the shapes of the drainage basins and the drainage divides and so on, and to figure out which areas are draining to which moulins. And so we went ahead and started that mapping process while we were stuck in the snow.
The tough wing glider the team has named the Ice Bat produces a detailed topographic map of the surrounding area, comparable to up-to-date satellite imagery. This mapping tool is critically valuable to the team as they try to orient themselves and track changes to the melting landscape over time. Dr. Covington compares this to survey data they brought with them.
Oh, I see what you're saying. So if you're coming back towards camp, this is downstream, and that's intersecting, right?
It looks like the biggest of the three. So, I don't know. I mean, this feature, I agree, does look a lot like what we saw.
Yeah. What I really need is a flamethrower.
You can call it a napalm drop.
Yeah.
You think CPS does those?
Yeah, I don't know. Hey, do you think we could order one of those?
Sorry?
Oh, so you think you could order a napalm drop from CFS in the morning?
Yeah, I'll get on that.
I know that we were funded to study all this water flowing into moulins, but look at this outrageous record that we have of snow accumulating in the middle of July.
We could start doing snow depth measurements.
Day 5, the snow gets deeper. You set up one of those like Houghton snow thermometers like back behind the tent.
Part of it's just being here. But we do want to come back. We're more likely to be able to come back if we can get some good data.
As daunting as the situation is, the team still has a few tricks up their sleeves.
If we find an image that looks like it might be the Moulin in the Tuffwing flight, we could possibly fly the quadcopter over looking for that feature, and basically you can get down really close and get it maybe 10 meters off the ground, look at the feature.
Okay.
It didn't stop snowing, it just got fluffy.
We also had a 3DR Solo quadcopter. Which mostly we were using for aerial filming, but it also turned out to be handy to do an initial search for the Moulin. We knew approximately where the Moulin was that we wanted to instrument. We didn't know exactly where it was with respect to our camp, and so we did a bunch of flights out from camp basically searching for it until we thought we had found it. Well, so if we go down here, we have to cross the channel here in what looks like a low swampy area, because these channels meet. There's no way to go through here and not cross the channel.
Okay.
So I'm just
What's
saying
the
maybe.
plans for tomorrow?
Yeah, so we can't do much because we don't know where the Moulin is yet. But so we're gonna wake up. If there's no wind, Matt's gonna fly a drone, try to find the Moulin. If that doesn't work, we'll go see what we can find from the ground. If it does work, then we'll go see what we can find from the ground, but with more direction.
Okay.
So if we can find a prominent T depression in the snow, then we know that we probably found the site. You know, I would hope that because the snow would be sagging into the Moulin or something, we'd be able to pick it out. But I don't know with all the snow that's drifted in the streams around here. So I mean, our original water area is completely buried under a snowbank now.
And Otherwise, we can also go on foot, see what we see.
Yeah.
So, but yeah, I mean, I'd be okay with running the ridge or something like that, all roped up tomorrow.
Yeah, maybe it'd be kind of nice to be able to scout around a little bit.
And you know, do something.
Just do something other than sit here. Yeah.
With the unknown terrain and the level of danger involved, only Dr. Covington, Dr. Gully, and Celia will venture out from camp. Dr. Covington carries with him a helmet-mounted camera to capture the trek. At any point, a team member could find themselves falling into a deep crevasse in the ice, so they will be fully connected with professional mountaineering harnesses. Over several days, the trio takes multiple journeys out onto the ice, looking for their target. Finally, it appears they have located the moulin. Now, the real work can begin. The team will install a complex system of instruments and infrastructure to support their research, which takes several days to set up.
So to study the moulins here on the ice sheet, we're lowering water level sensors, pressure sensors, deep inside the moulins, and potentially thousands of feet into the ice. And this allows us to measure how much the water is coming up in the moulin, which tells us how much water pressure there is at the base of the ice, which is directly important for the sliding of the ice. So we're lowering these pressure transducers in on a long cable that's built to withstand all of the forces that it might experience in the moulin. And then in addition, we're looking at the water that's flowing into the moulin, and we're doing that in a couple of ways. One of the ways is that we have sensors that can measure the height of the stream channel, the depth of the water in that stream, and we can relate that to how much water is actually flowing into the moulin at any given time. Since we're interested in motion of the ice, we're also using really high precision GPS units that are installed onto the ice in different locations to measure how quickly it's sliding. And in particular, we want to look at how the water going into the moulin then impacts, whether it does impact the motion of the ice, which is being measured by those GPSs. One of the ways that we're using to measure the flow in the streams on the ice sheet, and specifically the streams that are going into Moulins, is using a fluorescent dye.
This particular aspect of the expedition required a great deal of planning and preparation. Several months previous, Dr. Covington and another of his students, Brandon Conlon, developed the pumping system and carefully prepared several gallons of dye for the experiment.
And we have sensors that can detect this dye at very low concentrations in the stream. And upstream, we inject the dye using a pump. We pump dye into the water at a known rate. And by measuring that concentration downstream, we're able to actually calculate how much water is flowing in the stream.
Finally, the day has arrived, and the team will attempt the most crucial part of their experiment, probing the Moulin with a cable more than 750 meters long. Dr. Gully examines the Moulin one last time before the attempt, firmly anchored to the shoreline. He is taking no chances, as a fall into a Moulin can become a 1,000-foot drop into a one-way water slide. To safely lower the cable in a controlled manner, they drill steep holes into the ice in a V formation, feeding through nylon ropes and straps until they make a secure anchor, capable of supporting the hundreds of pounds of high-strength shielded cable. The cable must also be spread out over a long arc along its several hundred meters in length to prevent it from curling on itself. As the cable is fed into the Moulin, the team must watch out for the moving cable, which can be a deadly hazard if it runs out of control. As all preparations are finalized, Dr. Gully briefly reviews the plan with Dr. Covington. Once they get started, all communications will have to be by radio due to the high winds and how far the team will be spread out.
So when we first attempted to instrument the Moulin, we started lowering in cable and lowering in cable. And it seemed like everything was working all right. Cable was getting heavier. But we weren't hitting the water level. We weren't seeing any changes on the sensor. And once we got, 300 or 400 meters of cable in, we still hadn't hit the water. And we thought that was too far. We should have hit the water by then. And so we started trying to pull it out. And luckily we were able to pull it out. We pulled out a huge rat's nest of cable that had all gotten tangled up.
Making matters more complicated, the data they did receive from the sensor made no sense and only updated once every 30 seconds, or as the data logger was intended to function over the months it would be left on the ice sheet. They will have to figure out how to reprogram the software.
It was a little frustrating, a little bit surprising. Jason had instrumented 5 other Moulins before, and everything had always basically just gone in. But this time, for some reason, we weren't hitting the water, and we weren't exactly sure why that was.
Well, but I mean, like, I looked at it, and it's going straight down the water. It disappears in the spray. I can't. So, I
Poring over technical manuals, the team leads attempt to figure out the software problem.
So we just need to know which sensor it is, so we need to look at the serial number.
Okay, how different are the calibration constants?
They're really similar.
So we can ballpark it in a spreadsheet.
Each night it is left on the ice, the cable must be pulled out of a narrow trench it melts into, caused by its own dark color under the midnight sun. Dr. Covington takes the opportunity to fully set up his dye trace sensors across the Moulin Channel. As with the dye itself, Dr. Covington practiced these maneuvers back home in Arkansas before bringing the experiment to Greenland. The dye sensors must float near the surface directly in the middle of the stream for the experiment to work, and stay there for several weeks while the other instruments are running. The pump runs on a 12-volt battery and a tank of carefully diluted dye. Dr. Covington, assisted by Brandon, gave the pumps an endurance test ahead of time to ensure that everything would work correctly. Of course, not everything worked perfectly at first, but this gave Dr. Covington time to work out the bugs in the system. With the dye trace running, the team can turn their focus back to their sensor problem. How do you fix a software issue in the middle of nowhere on a glacier? Well, just like anywhere else, you call tech support.
Hey Jessica, how's it going? Yeah, good. So it's Jason up on the ice sheet again. Hey, we're still having some problems with data loggers. I was hoping you could have a short chat with Matt. Yeah, here you are.
Hey Jessica, it's Matt.
With the assistance of Dr. Cully's PhD student Jessica, Dr. Covington is able to reprogram the software to update every 5 seconds and gives precise readings in meters of depth. Now, they are ready to try again.
We decided to wait a few days and wait for a day when there was lots of melt that would maybe help to carry it in. That didn't work.
The team tries again and again with no success. And each time they have to stop and pull it out, they are lifting hundreds of pounds of cable against the massive water pressure of the Moulin flow. They keep trying, in conditions that range from fair to blizzard, barely able to hear each other over the driving wind.
We also tried lowering it from different angles to see if it was getting caught somewhere. Maybe if we lowered it from the other side of the Moulin, maybe then it would go in. Eventually we started hitting the water, but it was never going below a few meters of depth, and it was stopping at about the same depth any way we tried to lower it. The one last thing we tried is we actually tied on the parts of a broken chair, just the cloth from a broken chair that we had in camp, to give it a lot of drag so that the water would hopefully pull it in. But again, we just got the same results.
As conditions worsen again, the team begins to lose the struggle against the forces of nature. It starts to feel as though they won't succeed.
At this point, we started to think that the whole moulin might be going into a narrow crack, a narrow crevasse, the crevasse where the moulin had formed, and that at depth it just hadn't gotten large enough yet that the sensor could actually get through it. There just hadn't been enough melt yet. So at that point, we started thinking about trying to instrument a different moulin.
Finding the next moulin might be more difficult this time, as just a few days previous, tragedy struck one of the camp's most useful pieces of equipment. The ice bat has crashed, breaking its propeller completely off. Dr. Covington attempts to fix the tough wing with Celia's assistance, but they just don't have the spare parts they need to get it flying again. They're going to have to stick it out on foot with the information they have.
So we spent a day looking around and scouting out different potential moulins to instrument. And the one we eventually decided on was one that was really quite close to camp, only a couple hundred yards from camp. And one of the reasons for that was we were actually starting to run out of time. And it had the advantage that if we were unsuccessful, we could pull all the equipment and put it there in our camp to be stashed for the next year where we would try again.
Everything from the old site must be moved again and repositioned at this moulin, taking precious time away from getting this site instrumented and recording the data the team is after. Vicky and Celia drill out the new V anchor and set up the lowering harness. Dr. Gully prepares the team assignments and lays out his plan.
Vicky will be sitting at the computer, kind of same thing as last time, just give us a shout whenever you see like a spike in water level. If it hasn't been changing for a while and you're watching us feed cable in, just keep saying no change, no change, no change.
We started the next day trying to lower the cable into that moulin. We lowered the cable until it was about 50 feet under the water, but then it stopped going down. No change?
2.1.4, no change.
Okay. And we tried pulling it out a little bit, lowering it back in, and so on. We couldn't get it to go beyond that point. So at this point, at least we knew we were in the water. We weren't as deep as we were hoping to be, but it was a partial success in that we could at least capture most of the variability of the water levels in the Moulin.
Yeah. So the one of the GPS units is already in the ground, and we may put some more in here before we come off. One of the problems we've had, we have been unsuccessful in instrumenting the Moulin at low camp. We've tried, basically spent an entire week of tossing cable in and pulling it out and whatnot.
For Celia and Dr. Gully, their time at low camp has come to an end. They have to go back in order to prepare for the second camp of the season, where Dr. Gully will spend an additional 25 days attempting the same experiments on thicker ice. Meanwhile, Dr. Covington finally received the spare parts needed to repair the Tough Wing glider, which he now has time to turn his attention to. However, when he checks the Moulin sensor data the next day, he makes a surprising discovery.
And when you look at the rate at which it's increasing after that, it's really low compared to. So, I don't know. I'm optimistic we might get it further in. On our very last full day in camp, we had a couple of days of pretty strong melt, and the flow was really up in the stream. And we decided to give it one last try at lowering the cable. We started lowering it, and it went down. And we started lowering it, and it went down. And we lowered it some more, and it kept going down. It was glorious. We just kept lowering, and the water pressure kept going up. We were able to reach the water level about 200 meters, or a little over 600 feet below the ice surface. We reached the water level.
134.7. 136.3. 138.1. 140.
So we knew we were getting it deeper in, and we were able to lower it around 500 feet further into the water. And so at this point it was far enough in that we were pretty sure we would capture the full variation in water level. We have models, mathematical models, computer models of how flow of water beneath the glacier works, but typically we don't have access to the bottom of the glacier. And so this project is providing data that we can use to tune and better understand how our models should work.
Before it's time to leave, there's one more experiment to try. The ice bat flies again, taking one last mapping flight and bringing the summer's expedition to a successful close. Now, it's time to leave.
Okay, so it was cold in Greenland. And we think that the reason we were having all this trouble with instrumenting the new lens was a lack of meltwater. Once things started melting more strongly right at the end, we were successful. And so we have now several months worth of Moulin water level data from both of these sites. The blue line
At both of our camps, the camp at the thinner ice and the camp at the thicker ice, we were successful in instrumenting the Moulin after some effort. And looking at the data, we were a little bit surprised, particularly in what we saw at the thicker ice site. The water level was not changing very much. And also the water level was staying quite high during the whole period. And the reason that we think that is happening is because the conduits in the ice, they can grow by melting, but they also can shrink from the pressure of the ice. The ice itself slowly flows. And so when you drop the water pressures, it'll start squeezing those tubes shut. And the thicker the ice is, the faster it'll squeeze shut. The general thought in recent years had been that this Zwally effect, where meltwater accelerates the ice, was not going to be too important in the end, because as you introduce more meltwater, the flow paths in the ice become bigger, and actually eventually your water pressures drop. Our data suggests that might not be the case as you move to thicker and thicker ice. It could be that in places where there's very thick ice, it could be that meltwater will have a bigger impact on ice motion as melt starts to occur further and further up the ice sheet. Our data are sort of opening that question back up. Could it be that at thicker ice, meltwater will have a continued impact on ice acceleration?
Science is a difficult and demanding process. Under adverse conditions and incredible odds, the Gully Project has been a success, allowing the team to return for another 2 seasons on the ice. They'll be back in the summer of 2018 to face the unknown again. This program was made possible in part by a grant from the National Science Foundation, where discoveries begin. And by contributions to your PBS station by viewers like you. Thank you.